click the red subscribe button right under the video and also the bell icon to get notification on any of our latest updates on the videos.
Hello, good day everyone. Welcome you to another tutorials by Smart Bukites, and today we're going to deal with differential equation, and we are going to solve a question under second order non-homogeneous differential equation using undetermined coefficient method. And this is the question we're given. Use the method of undetermined coefficient to solve y prime prime plus 4y prime plus 3y is equal to exponential negative x. We are given some boundary or initial conditions. The boundary conditions are y of 0 is equal to 2. That means when x is 0, y is 2. And y prime of 0 equals 1. That means when x is 0, y prime or dy dx is equal to 1. So now let's get to the solution. This is the equation we are given. So this is non-homogeneous differential equation confirmed. Why? We have a proof from the right hand side here. Because for a homogeneous differential equation, always the right hand side is equal to 0. That means this is homogeneous. But for non-homogeneous, the right hand side will be a function of x. That means it can be a polynomial, x power n, it can be exponential, it can be trigonometric function, and all the sort of things. And whatever you have at the right hand side of your equation, it have a different method of solving it. So here we have an exponential function, and we will come to the solution. So the first thing to do is to bring out the auxiliary equation. That means here from y prime prime we will say m square plus 4m plus 3 is equal to 0. The auxiliary equation, that's just right, the left hand side, and it's in a form of quadratic equation. We will solve the quadratic equation and get the roots of the auxiliary equation. The roots of our quadratic equation are the roots of our auxiliary equation. So we can solve this equation using factorization. Really, yeah, you can say m square plus 3m plus m plus 3 giving us 0, right? So here we have m into m plus 3 plus what? 1 into m plus 3 giving us 0. We can say m plus 3 in m plus 1 is equal to 0. So this means that either m plus 3 is equal to 0 or m plus 1 is equal to 0, which means that here we have m is equal to negative 3 or m is equal to negative 1. So this is our roots of the auxiliary equation. Here we have m1 as minus 3 and m2 as minus 1. So this, we can call it the complementary function. That's what we're going to write using this roots of auxiliary function. The complementary function have different ways of writing it. Be it the roots of the auxiliary equation, if there are two distinct roots, if there are double roots, equal roots, that means m1 is equal to m2, or if there are imaginary roots. But since here we have two distinct roots, the complementary function is y is equal to a exponential m1x plus b exponential m2x, and we have our m1 and m2. So now the complementary function, since we have m1 and m2, is y is equal to a exponential negative 3x plus b exponential negative x. That's minus 1 times x is minus x. This is our complementary function. Now the particular integral part. The particular integral part is where we are going to solve for the right hand side of our equation. Now the right hand side is exponential of negative x. So we have right hand side is equal to exponential of negative x. So this shows that our right hand side, or the particular integral part, is an exponential function. That's exponential of negative x. So for exponential function, as I told you that every type of function have its own way of solving it. So for exponential function, it states that if we have exponential alpha x, then what we are going to use for the particular integral solution is y is equal to c exponential of alpha x. That's rule 1 for exponential function. But if alpha is a root of the auxiliary equation, is either of the roots of the auxiliary equation. Here you see that we have the roots of the auxiliary equations from the above as m1 and m2. Supposing that alpha is equal to m1 or alpha is equal to m2, that means if alpha is a root of the auxiliary equation, we will change it to y is equal to cx exponential of alpha x. This is the second rule, rule number 2 for auxiliary for exponential function at the right hand side. And it can be that the auxiliary equation have two equal roots, m1 is equal to m2. So if m1 is equal to m2, and luckily you have that alpha is equal to m1 and is equal to m2, that means you have two equal roots, then your equation will change to y is equal to cx square exponential of alpha x. Yeah, here is not n, I'm sorry. Exponential of alpha x. This is the third rule. These are the rules we have to solve the right hand side of a non-homogeneous second order differential equation if the right hand side is an exponential function. So this is what we have here for our right hand side, exponential of negative x. So if we relate this to exponential of alpha x, we will see that our alpha is equal to -1. And back to our auxiliary equation, the roots of the auxiliary equation, we can see that our alpha is equal to m2, -1, right? So since our alpha is equal to -1, we are going to use the second rule. So here we are going to say y is equal to cx exponential of alpha is -1 minus x. This is what we have for our right hand side. So we differentiate it. We have y, since from the equation, the first equation, we have y. We have y prime, that's dy dx, and we have y prime prime or y double prime, which is what? d2y by dx square. So here we have y, we'll say then dy or y prime, dy by dx or y prime. Which one? Y prime, which is the same thing as dy by dx. I'm going to differentiate it and I have it. But let's come to this. You can see that my y is of two functions. I have cx and I have exponential minus x, which shows like something to say I have y is equal to uv. And you know that if we have y equal to uv, we know that dy by dx is going to be what? U dv plus v du. That's how to differentiate it, right? So from that, my equation, we can say that let u be equal to cx. Therefore, du by dx, or du by dx, yeah, du is equal to what? C, differentiating with respect to x. And let v be equal to exponential of minus x. Then dv by dx, or dv, the same thing, is going to be what? Negative exponential of negative x. So applying the rule and going back to differentiate it, here we say u dv, what's our u? cx, right? Cx multiplied by dv, which is negative exponential of negative x, then plus v, what's our v? Exponential of negative x times du, which is c. So here we have y prime, which is dy by dx, to be negative cx exponential of negative x plus c exponential of negative x. So here we can say that we have c and exponential of negative x to be common. So we can say y prime, which is dy by dx, is equal to c exponential of negative x into, here I will say negative x and here I will say plus 1, or preferably it will be c exponential of negative x into 1 minus x. So this is my y prime, or dy by dx. This is y prime. So going to y prime prime, which is d2y by dx square, I'm going to do the same thing to differentiate this c exponential of negative x multiplied by 1 minus x. So for this part, let me say, coming here, the same thing, y is equal to uv, then let my u be c exponential of minus x, and then what's going to be my du by dx? Is going to be negative c exponential of negative x, and let v be 1 minus x. If I have 1 minus x as my v, what's going to be dv? Differentiating is going to be negative 1. This is what I have. So differentiating this, what's our u? C exponential of minus x multiplied by dv, which is minus 1, then plus, what's v? Plus v du, that's v1 minus x multiplied by du, that's minus c exponential of minus x. So here I will say I have minus c that's y prime prime is equal to minus c exponential of minus x plus into 1 times minus cx, that's minus c exponential of minus x, then minus x times minus this, then plus cx exponential of minus x. Here I'll say y prime prime is equal to minus 2c exponential of minus x plus cx exponential of minus x. The same thing, I have c and exponential of minus x to be common. I'll say y prime prime is equal to c exponential of minus x into minus 2 plus x, or c exponential of minus x into x minus 2. Now I have my y prime prime. So writing my equation, y prime prime plus 4y prime plus 3y is equal to exponential of minus x. That's from the question. This is the equation I'm given. So I'm going to write it on the basis of the right hand side of the equation. So that's exponential x, how I got it from the particular integral part. Now what's y prime prime? That's c exponential negative x into x minus 2 plus 4 times y prime, that's 4 into, what's my y prime? C exponential negative x into 1 minus x, then plus 3y. 3, what's my y? That's cx exponential of negative x. Cx exponential of negative x is equal to exponential negative x. Expanding this, I will have cx exponential of negative x minus 2c exponential of minus x plus 4, first inside the bracket, that's c exponential of negative x minus cx exponential of negative x plus 3cx exponential of negative x is equal to exponential of negative x. So here I can say cx exponential of negative x minus 2c exponential of negative x plus 4c exponential of negative x minus 4cx exponential of negative x plus 3cx exponential of negative x is equal to exponential of negative x. Here now cx exponential negative x plus 3cx exponential negative x will give me 4cx exponential negative x, and I can subtract it here to give me 4 minus 4, that's 0. Here minus 2 plus 4, that's 2. In total, I will say I have 2c exponential of negative x is equal to exponential of negative x. Yeah, here I will say exponential of negative x cancel exponential of negative x, 2c is equal to 1. Therefore, c is equal to 1 over 2. In total, from the particular integral part, remember this part, I have my y to be cx exponential of negative x. So the particular integral part, I have y is equal to cx exponential of negative x, and my c is half, therefore 1 over 2x exponential of negative x. So the general solution of my differential equation, which is the complementary solution plus the particular integral, will then be, what's the complementary solution? Y is equal to a exponential of minus 3x plus b exponential of minus x. That's a exponential of minus 3x plus b exponential of minus x, then plus the particular integral, that's cx. I've already gotten my c to be a half, that's 1 over 2x exponential of negative x. This is y general solution. Had it been I'm not given any initial condition or boundary condition, I'll be done here. This is my general solution of my differential equation. But recall that I'm given some boundary conditions. Given that y of 0 is equal to 2 and y prime of 0 is equal to 1. But I'm going to use this to determine my a and b. Just like I did for the particular integral part, I found c to be half. So using these boundary conditions I'm given, I'll find my a and I'll find my b. So recall my complementary function. The complementary function, that's the part with the a and b. I have gotten y is equal to a exponential minus 3x, right? And plus b exponential minus x. This is y. Replace x by 0 here and y by 2. But since I'm going to use two equations, that's that of the y prime and that's of y, let me find y prime here. That's dy by dx. Y prime, differentiating this, I'll get minus 3a exponential of minus 3x plus here differentiating this, it gives me minus b. So directly minus b exponential of minus x. So this is my y prime. Let me call this equation 1, and equation 2. In equation 1, I'm going to use the first boundary conditions. That's y is equal to 2. 2 is equal to a exponential minus 3x. My x is 0. 3 times 0 is 0. Minus 0 and 0 all the same, therefore exponential 0. Plus b exponential minus x is minus 0 is equal to 0. And we all know that exponential 0 is equal to 1. exponential 0 is equal to 1. So a times 1 is a, b times 1 is b. So now I can say a plus b is equal to 2. Get my equation 3 here. So now in my equation 2, I'm going to use the second boundary condition. Second condition. So what's y prime? 1, right? 1 is equal to minus 3a exponential. Minus 3x is minus 3 times 0, that's 0. Minus b exponential, minus 0 is 0. Here too, the same thing, exponential 0 is 1. Here too, exponential 0 is 1. So my equation will now be minus 3a minus b is equal to 1. This is equation 4. So I can change b to be the subject of the formula in this equation 4 to have b is equal to minus 3a minus 1. Substituting this, substitute b is equal to minus 3a minus 1 in equation 3. If I substitute it, what do I have? What's my equation 3? A plus b is equal to 2. That means a plus b. My b now is minus 3a minus 1 is equal to 2. Here I have minus 2a is equal to 3, which means a is equal to minus 3 over 2. Final. Then I'm now going to find b from equation 3. Using the value of a I've gotten as negative 3 over 2. My equation 3, which says a plus b is equal to 2, and now you know a is minus 3 over 2, so minus 3 over 2 plus b is equal to 2. So now I can say b is equal to 2 plus 3 over 2. Now here I can say b is equal to LCM 2 here, 4 plus 3, which will give me 7 over 2. So now I have my a as minus 3 over 2 and b as 7 over 2. So the general solution now, that's the final step. It gives me y is equal to a exponential negative 3x, right? And now my a is minus 3 over 2 exponential of minus 3x, then plus b exponential minus x, which is 7 over 2 exponential of minus x, then plus, this is the complementary solution. Then the second part, that's the particular integral. I have cx exponential of negative x, which is 1 over 2 at my cx exponential of minus x. This is the final solution of my question. I hope we all get this. For any misunderstanding, question, or any compliment, we're waiting for you in the comment section. Thank you very much.